active standby failover. If we need fault tolerance inside of a system, it usually involves two devices. By implementing two ASA firewalls in an active standby failover configuration, we can provide that fault tolerance for our network. In this MicroNugget, we're going to take a look at exactly that. What is it that users really want from the networks? I've discovered it's two basic things. They want the network to work, and they want it to be fairly fast. So when this user goes out to the internet, they expect it just to happen. Now behind the scenes, if we want that to happen even though there's a fault, we can implement some fault tolerance by having redundant systems. And that's what active standby failover is all about. Now to do this, the ingredients that go in the recipe for active standby failover is you need two firewalls. So why buy one when you can buy two at twice the price? So you get two firewalls and you configure one as primary and one as secondary. Now on a good day when these both boot up, they chat with each other, the primary one is going to take the role of being active. Now it's good to be active. It's good to exercise, it's good to move. And in active standby failover, active simply means this is the ASA that's doing the forwarding. So when Bob goes out to cbtnuggets.com, it's this firewall in measurable terms that's forwarding the packet and maintaining the session state table so the reply traffic can come back. So what is this guy doing? This is the job that a lot of people wish they had, being the secondary. He doesn't do a lot of anything except make sure that the active system is okay and still forwarding traffic. He takes the role of something called standby. You mean as in stand by and watch the other guy work? Yes, that's exactly what it is. So this standby unit is simply checking the interfaces. They're checking across the failover cables just to make sure the other guy's fine. And if he's fine, he just sits there as a backup. Now, if something bad happens, for example, somebody just powers off the system, what happens in the background before that occurred, before the failure, the stateful information can be replicated from the active firewall to the standby. So if Bob had a translation going through the firewall at layer 3, or if he had some sessions that were open and the reply traffic was coming back, all of that real time can be replicated to this standby unit so that if the standby has to go active, because this guy up here went away, somebody powered him off accidentally, or it has system failure, Bob won't be interrupted, he can still forward traffic. So in this MicroNugget, we're going to take a look at what is active standby failover, which is exactly that, where we have two devices, one's active, one's standby. If there's a problem, they revert roles, so the secondary would become active. And how do we confirm a failover state? Let's take a look at that. Let's bring up a command line interface for these ASAs, and here is ASA 1 and here's ASA 2. Now if you look at them, they both have the same host name, and that's because the configurations are replicated. However, I've set up the prompt to indicate that this is the primary unit and this is the secondary unit, and currently the primary is active and the secondary is acting in standby. To verify their state, besides just changing the prompt, you could also do a show failover, and that would show us, and it has, besides of a ton of information, it says this host is the primary device and it's currently active. The other host is the secondary device and it's currently in a standby state. So let's test this out. If we brought up a browser, and this is a great example of it. So here we have a website, cbtnuggets.com. And let's do a quick ping as well. So we bring up a command prompt and do a ping out to 8.8.8.8. So the ping is functioning. It's going through the active firewall at the moment. No problem whatsoever. We can also open up a video. We'll go to this one right here, the first one. And I'm going to turn off the audio so you can listen to me and not it. So this is playing the audio, and it's going to queue up right here. We can see the actual caching of the play before it gets there. Now if we wanted to, I'm going to go ahead and leave that playing. We can go in the background, and on the active device right here, in fact, before we do that, I've got a few extra moments. I'm going to go ahead and show you a really awesome thing. Right now, we are synchronizing all the connections and translations between the two firewalls in case there's a failure. So if we do a show xlate, which is how you ask an ASA to show us the translations, this is on the first ASA, and this is the second ASA. So I did a chat to all tabs for the same command. So you notice they both have the translation of this inside PC going out to CBT Nuggets website. And check this out. If we do a show con, has the connections. So the connections here should reflect the connections here. So as they go back and forth, because both firewalls know about all the connections and everything else, one's active, one standby. If I rebooted the active device, we should still be in good shape. So let's go ahead and take the active device and say goodbye. I'm gonna do a write just to make sure I save my config. That write, by the way, will also cause a write on the secondary unit, which is acting as the standby. And let's reload him. So he is now gone. Now we take a look at the standby unit here. He is polling every second to the active, or what was the active unit. And in just a moment, he's going to realize, oh no, the active unit is no longer responding. I better change. And here we go. So we're switching to active mode. And if you notice, the prompt changed. So back at the client, the video is still running. And because of the buffering this is a YouTube channel, just because of the buffering, the user wouldn't even notice the few seconds it took for the failover to occur because of the caching that's involved. So in this MicroNugget, we took a look at the concept of active standby failover with one device being active, the other device being a standby. If there's a problem or the other one gets rebooted or there's an issue, the role can switch, and the one that was standby can then become active and take over the role of forwarding traffic on the network. We also took a look at how to confirm the state of a failover device with show failover, and then we also forced a failover by simply taking the primary and rebooting him. By doing the reboot, the secondary firewall, which was currently standby, didn't see the poll messages being responded to and said, oh, the other guy must have a problem, and went active. I hope this has been informative for you, and I'd like to thank you for viewing.